is on trig identities. You guys already took a quiz on this, so we don't have to talk about that. Took a quiz on this, so you don't have to talk about that. So we get to jump straight down here, where you learn how to rewrite and manipulate trig expressions to a desired outcome. So we're supposed to simplify the tangent of theta over the secant of theta by writing each function in terms of sine and cosine, because we'll see some cancellations, okay? You know, it's the idea is simplify. That's the idea, simplify. What is this really? Well, what is tangent in terms of sine and cosine? Tangent is sine over cosine. So we have the sine of something divided by the cosine of something. And then we rewrite secant. How do you rewrite secant? 1 over cosine from your quotient identities. Not your quotient, reciprocals. 1 divided by cosine of theta. There's a lot of ways of approaching this problem from here. I have always taught kids that if something was in the same spot, what happened to it? It cancels, okay? So do I get to strike the cosines out of existence? You know, and what I'm left with when I do that is sine of theta divided by 1 divided by 1. Isn't that right? Just think about the next step. That's what it looks like. 1 over 1 is 1. So what do you really just have left? Sine. That's sine of theta. So when you do trig identities, as we move on in notes, you know, start thinking about what each of these trig functions are, how they can each be rewritten. You're just going to have to imagine and just practice and play and erase and start over. You really are. This is kind of an interesting thing. Show that the sine of theta divided by 1 plus the cosine of theta is 1 minus cosine theta over sine of theta by multiplying the numerator and denominator by 1 minus cosine of theta. There's a relationship between these two pieces. There's a word. Remember the word that describes the relationship between those two? No. How do you clean up 1 over 2 minus the root of 3? Multiply it by what? No. What, Trevor? No. Didn't y'all all take like college algebra 140? Must be an algebra 2 teacher's fault. Multiply the top and bottom by 2 plus the root of 3. Multiply by the conjugate. So what they're trying to show you is that the idea of multiplying by a conjugate is still a nice way of cleaning something up. The conjugate of 1 plus the cosine of theta is 1 minus the cosine of theta. They are conjugates to each other. So it's an old skill that still applies. Use conjugate. So the goal is to make the left match the right. So we're just going to do what they tell us to do. Multiply the top and bottom by 1 minus the cosine of theta. Now, as you gain experience and practice, you'll learn to just leave the top factored. I think that sounds right. It's been a minute since I've done these myself. But it's usually a good idea to leave the top factored because what you want to do is you want to manipulate the heck out of the bottom piece and see what happens. What would Jesus do with the bottom? He'd foil. He would foil. I saw something on Facebook last night by a pastor and it just surprised me. Only 48% of this country believes Jesus is God. I think the rest just say he was a good teacher. Ooh. You think 2020 was bad, kids? It's about to get a lot worse. But Jesus would foil that thing. And Jesus was a teacher. It was his first title. first title man gave him anyways. 1 times negative cosine of theta. 1 times 1 is 1. Here we got a plus a cosine of theta. 1 times a cosine of theta. And last, we have a positive cosine of theta times a negative cosine of theta. What's that going to create for us? You're really close. Squared. It's like x times x. Minus cosine squared of theta. Now there's a reason I'm kind of doing this piece off to the side here. Those pieces cancel. And I'm stuck with 1 minus cosine squared of theta. You just took a quiz where you listed off 3 Pythagorean identities. What was the first one? That was the first one. That's right. Sine squared theta plus cosine squared theta is 1. Solve that thing for sine. Solve that identity for sine squared. Sine squared of theta is 1 minus cosine squared of theta. So see, I can take this 1 minus cosine squared theta and just replace it with what? Sine squared. You see that? They're the same thing. So I'm going to put that in up there. Now, I focus my attention on that. What's x over x squared? Go back to algebra 1. What's x over x squared? Literally, I guess we need to go back to algebra 1. I made this joke this morning, and I shouldn't have because it's on YouTube now, and it's going to be on here again. Did you all ride the short bus? Funny thing is, from Palmersville, the short bus is not a short bus. It is a full-size bus. It was last year. I don't know if it is this year, but last year it was a regular bus. Oh. Okay, kids, let's go off to the side again. X over x squared. Now you think about this as 1 over x times x. Don't you get to kind of throw something away like that? It's 1 over x. All right, so again, sine over sine squared. Just a sine where? On the bottom. Did we do what was asked? Does the left-hand side, in fact, equal the right-hand side? That's the goal. Make the left hand equal the right hand, or vice versa. You can make the right hand look like the left-hand side. But the idea is generally to approach and attack the left-hand side. That's the goal. That's what trig identities are really, really about. Teaching manipulation. But that manipulation requires a ton of memorization. Because if you don't know it, it doesn't matter if you got a sheet of paper in front of you. If it's not right there, you won't ever see it. You understand that? It has to be there. All right, well, here we got one that wants us to add fractions together. Simplify 1 over 1 minus a sine of u plus 1 over 1 plus a sine of u by rewriting the expression over a common denominator. Was that me or y'all? That must be me. This could be interesting. No. My wife is following a married couple that she thinks is about to break up. So she has to send me all the information on it. All right, back to this. Rewrite the expression over a column. All right, so we're adding fractions. Let's just do it with numbers, because if it works for numbers, it works for any algebraic technique. Now, I know when you did this lesson in 5th grade, they taught you to give everything a common denominator, right? Well, what are you going to multiply both the 1 and the 3 by? 5. How about this 4? 3. Well, there's another way of saying that. You multiply the 1 by 5, you know that. You multiply the 4 by 3, you knew you were going to do that, right? And if you just multiply the bottom pieces together, don't you accomplish the same thing? That's how you added numbers. Maybe not exactly that way, but that's what was going on in the background. That's how you added numbers. And if that's how you add numbers, that's how you add expressions. So that's exactly what we're going to do. What am I going to give this 1? The first one I see. Yeah, the 1 plus. Some kids like to say, oh, it's cross multiplication. Yeah, I know what you mean, but don't call it that. Okay? Yeah, you're going to give this one that 1 plus sign of u. You don't have to show it here because it's a 1, but I'm going to. How about the other one? 1 minus sign of u. What do we do with the bottom pieces? Multiply them together. Really should have left a lot more room here. Don't know what I was thinking. If you're a kid who's not wrapping things up in parentheses properly, you kind of need to or you'll lose your place. The bottom is going to clean up quite a bit for, or not the bottom, the numerator is going to clean up quite a bit for us. Looks like, you know, these ones are understood, so throw them away. 1 and 1 makes 2, right? That's pretty simple. What happens to signs? They cancel. One's positive, one's negative, they're gone. The bottom we're going to have to do some work with. Why don't you try to FOIL that denominator? FOIL it out. See what you get. If you're at home watching the video, why don't you try to FOIL it instead of fast forwarding it? Because that's what you're going to do. That's what I would do. How's it go? Do as I say, not as I do? That lesson, but does that make any sense to y'all at your age? It will. It will make perfect sense soon. As soon as you're responsible for somebody younger or smaller than you, it will make perfect sense. Trevor, you look done. Riley, you done? Is Jesus going to be proud of you? Hope so. I don't think he cares too much about the math, to be honest with you. But I don't think he wants you to be uneducated either. What'd you guys get when you filled that out? That sounds right to me. Anybody take that a step farther? No. Jesus might not be disappointed, but I am. Take it a step farther. Pythagorean identities. Cosine squared, isn't it? I think it's the same one we just did. Almost certain it is. For those of you at home or for those of you just tuned in, cosine squared plus sine squared is 1. And we can manipulate this. Just move that guy on over. That's where that comes from. So we have 2 over the cosine squared of theta, and there is another rewrite you can do.
Do we use theta or the?
Oh, I don't know. I don't know. I like theta. Anybody got an idea? I'm telling you, it's not done. It's not actually in the identities you memorized, but there's something very, very close to something. Don't even worry about the 2. There is a cosine on the bottom. Secant. It's not secant, it's secant squared. And there's a 2 up top. So it's twice secant squared. Are you good with that? No? Okay. So don't even worry about the 2. The 2 has to be there, right? You okay with that? You know, secant is 1 over cosine. Did you know that? So secant times secant would have to be 1 over cosine times 1 over cosine, which is 1 over cosine squared. Good, Julie? Elizabeth? By the way, Elizabeth, you are a liar. I went to my video. HD is an option. It's 1080p. She said it was only 144. Your internet sucks. By factoring. Oh, that still applies? Oh, no. I see a difference of 2 squares up top. Bottom's actually easier to factor. Let's start there. Start small. What do both pieces possess? If you just focus on the denominator. They both possess sine of v. So you can pull out that sine of v. And you'll be left with 1 plus cosine v. Now, when it comes to the top, this 1 minus cosine squared of x, people will probably teach a u method here. So I will too. Think 1 minus u squared. Or x squared if you like x's. Heck, let's make it an x. 1 minus x squared. That's 1 plus x, 1 minus x. Okay, that's a difference of 2 squares pattern. But it wasn't x. It was cosine, wasn't it? We're just thinking about something square, and it was cosine. So the top is 1 plus cosine, in this case v, and 1 minus cosine v. Then you go back to your Algebra 2 and 140 lessons, and you throw some stuff away. So this is going to be 1 minus the cosine of v sitting over the sine of v. There is actually a little more that can be done with a problem like this. And it's worth talking about. I'm not trying to confuse you. I'm really not, believe it or not. Can you break 3 plus 5 over 7 into 2 fractions for me? Break it into 2 fractions. Everybody okay with that? Do the same for that. Break apart 1 minus the cosine of v over the sine of v. What's it look like? Minus cosine v over sine v. Now let's make this thing not a fraction. Because it doesn't have to be. What's 1 over sine? Cosecant. How about cosine over sine? Cotangent. Anybody got any questions so far? I know it's a lot. I know that you will struggle with it.
You said, when I got done with that one, you said, that was a way we could do it. Is that the correct, are they both the correct answer? Like, 1 minus cosine.
They are exactly the same, and it's going to depend on what the question wants you to do. The question will give you an idea of what you want. It'll say, prove this equals that. So you stop whenever this equals that. Okay? That's when you stop. I'm just showing you that there's a lot of manipulation that can be done. Let's see. Oh, here's one of these. Make this look like that. Okay? Left hand equals right hand. That's all. I always start with the more complex looking side as opposed to the easy looking side. And there's 6 of you in here. Surely you can come up with some techniques. Tell me what you want to do. Why not? You can, can't you? Why not? So sine of theta, cotangent of theta, plus sine of theta, tangent of theta. It's not equal to anything yet, because we don't have a clue what it's going to look like yet. Now those things aren't alike. One of them's got a cotangent, one of them's got a tangent. Seems like one of the first things in your notes was to rewrite things in terms of sine and cosine, wasn't it? Might be a good idea. Is there anything we can rewrite in terms of sine and cosine? Cotangent, yeah, and tangent. So cotangent is cosine over sine. Tangent, oops, I don't know why I put that divisor there, sorry. Tangent is sine over cosine. Got a cancellation. Cosine theta plus sine squared of theta over cosine theta. Sine times sine being sine squared. Bless you. And you sneezed in a mask, didn't you? Just pull it down and dab. And now you got to breathe that in all day. I know, but that's, you're not supposed to breathe that in all day. What do you want to do here? What's cosine of theta understood to exist over? These are actually two fractions, kids. They are. You see two fractions, can't you add them together? So maybe that's a good idea. What do I give this cosine right here? I give it cosine. What do I give sine squared? I give it a 1. And what's the denominator going to be? The product of 1 and cosine, which is cosine. Well, I don't want to write too many more lines here. What's the top line say if you multiply your cosines together? It says cosine squared plus sine squared, which is what? 1. So now we're sitting at 1 over cosine of theta, which happens to be secant. And we get to stop. Why? That was the goal. Prove this is that. Now, I don't know if you like this stuff or not. I actually kind of like this stuff. But apparently I'm different. It's like a little puzzle to me. And you do actually have to listen to SpongeBob here. He's not kidding. You do have to use your imagination. And you guys have the benefit that I've done these things, so I know how they all work. You're going to be erasing and staring and giving up and coming back. Hopefully you come back to it. Don't just give up. Keep trying. Figure it out. So here's a relatively easy one. It says establish this identity. Of course, you already know the identity is true, right? This one says establish, so make it true. Now, the identity that you have doesn't have negative symbols in it, but we know it's going to be 1. Just make it true. So what we need to do is we need it to look like sine squared plus cosine squared, just a regular positive angle, because that's the identity that you have, okay? It's not hard to do. You just wrote this down on a piece of paper. Cosine of a negative theta is cosine of a positive theta. So that's done. That's just a straight up erase that negative symbol. That's easy enough. When it comes to this one, what's the sine of a negative angle? It's the negative sine of a positive angle. So if we have, I got the squares in the wrong spot, sorry. But this is squared, so we multiply it by itself. What's a negative times a negative? Positive. Does it look like it needed to look? Positive smiley face, whatever. Does it look like it needed to look? Then the identity is done. Because you know for a fact that is 1. So just an odd little easy identity.
So do we put equals 1 in that?
I mean, yeah, 1 equals 1. It's up to you. I have to grade this stuff. This stuff isn't on Excel. And some days I am capable of thought. All right, here's another one. Prove that cosecant of theta minus cotangent of theta is sine of theta divided by 1 plus the cosine of theta. Give me an idea. If it's wrong, we'll start over. Hey, those are 2 fractions that are actually alike, aren't they? Which means I can just put them together. How do you add 1 over sine, take away cosine over sine? I guarantee you there's somebody in here that's just like, I don't understand that. It's the same thing as saying 3/4 minus 1/4. Common denominator, just do what it tells you to do. Leave the denominator the same. Okay? That doesn't look like what we want, but boy, it sure does look close. Does anybody have an idea? I tried to refresh a vocabulary word for you at the very beginning of class. What was that vocabulary word? Conjugate. Conjugate. Conjugate of what? 1 minus cosine or sine? No. The complex looking piece is what you always multiply by, the conjugate of that. You're going to use the conjugate, but you're going to use the conjugate of the numerator to do it. So you're just going to use the conjugate. What is the conjugate of 1 take away the cosine of theta? Come on, it's literally on the piece of paper. 1 plus. It's giving you a hint. That has to be in the bottom, doesn't it? You're going to have to multiply the top and bottom by 1 plus cosine theta at some point in your life. Now, I wouldn't do anything with the bottom. Wouldn't touch it. I'd focus on the numerator. So FOIL like JC. And think about good old Pythagoras. There you go. Sorry, Zach's a little quicker than a couple of y'all, but he's right. When you FOIL out 1 minus cosine of theta and 1 plus cosine of theta, you're going to end up with 1 minus cosine squared. You're actually going to have 1 plus cosine of theta minus cosine of theta minus cosine squared of theta. But the top does clean up to be 1 minus cosine squared of theta. The bottom you just leave alone. You know, don't put those together. You'll understand that as you do some of these on your own. If you try and put them together, you're just going to have a big mess. Plus, you want that piece. You want that piece there. Don't ruin it. You've got it. It's a piece of the puzzle. You already know where it goes. Crawford was thinking about his Pythagorean identities. Hopefully you guys are too, at least by now. Sine squared theta over sine of theta times 1 plus cosine theta. Here we have x squared over x. First thing we talked about was x over x squared, but this is backwards. It's x squared over x. One sign up top. Now we get to throw away that exponent, get to throw away all that. So 1 over 1 plus, 1 sine over 1 plus cosine of theta. And the left matches the right. How much have I got left here? I'm going to stop and I'll start up here tomorrow because I need to do enough examples tomorrow to at least refresh you, because I can't just do like one example. Be like, there you go. So I'm going to stop there and do these last 4 tomorrow. If you haven't finished your IXL, good time to do that. I don't have this worksheet ready, so I can't give it to you yet because I haven't made it yet. I'm going to give you a piece of paper tomorrow.